Now we'll talk about equations for circles. So again, we're going to kind of use this right triangle Pythagorean theorem relationship to just talk about why the equation is what it is for circles. So looking at this circle below, suppose we want to come up with an equation for it. So the two components of a circle that we're going to talk about over and over again are the center of a circle and the radius of the circle. So you can see that the center of the circle is here at 0, 0, right? So the center is 0, 0 at the origin. And then the radius of the circle, you can go from the center to any point on the edge of the circle, on the circumference. And I just traveled to the right a distance of 3, right? So the radius from the center out to the actual circumference of the circle is 3. And I can go any direction from the center straight up to 3. To the left, I go out 3, and down I would go 3 as well. So the radius is from the center to the actual circle itself. So the center is 0, 0, and then we say the radius r equals 3. Okay, so let's suppose that we want to create an equation to represent this circle. We want to represent all of these points on the circle. So this point, this point, this point, this point right here, all these points on the circle. And there's got to be a relationship between the x and y values on this circle for all of our x, y coordinates. So again, we know that for any right triangle, it's true that a squared plus b squared equals c squared. So here's the center of our circle at 0, 0. Here's a point on the circle. But notice that I could have created a right triangle for any point on the circle, right? I could identify any point like here, here, whatever, and I could create this right triangle, okay? So I just picked this random point here. So I want to use the Pythagorean theorem. If this is A and this is B and my hypotenuse is C, then I know that a squared plus b squared equals c squared. Or another way to think of this is for this point, which is some xy ordered pair, this a distance down here will be whatever x is. So it looks like it's maybe like 1.5-ish, somewhere in that neighborhood. So if we think of a as x, and then this b value, it looks like maybe it's, I don't know, 2.75 or something in that neighborhood, but this height b is going to be whatever our y value is here on the y-axis, so b is y. I know c, I know the radius is 3. That's a distance that I actually already know. Then I can rewrite this as x squared plus, y squared equals 3 squared, or simplified, x squared plus y squared equals 9, right? So x squared plus y squared equals 9 is the equation for this circle. And that would create a relationship between any xy ordered pair. So if you identify any xy ordered pair on the graph, you know that it's true that x squared plus y squared will equal 9. And let's just test it out. Let's pick an easy point that we know. So for example, over here, I can see that that's going to be the ordered pair -3, 0, right? So let's see if this relationship holds. -3 squared plus 0 squared for y. That would equal 9, right? -3 in parentheses squared is 9, 0 squared is 0, and that does equal 9. So it'll work for any point on the circle. Okay, so what we'll notice is for any circle that is centered at 0, 0, centered at the origin, we can write the equation for the circle as x squared plus y squared equals r squared, whatever the radius squared is. And notice that we didn't leave our previous equation saying equals 3 squared. We went ahead and simplified 3 squared as 9. But this is how we can get to that formula. X squared plus y squared equals r squared. And then remember just to simplify that constant squared on the right-hand side, okay? And this is our formula for circles centered at 0, 0. We'll see what happens when we shift them away from the origin center later on. So just 3 examples. We've got 3 circles centered at 0, 0, a circle with a radius of 1. The equation for that circle would be x squared plus y squared equals 1. And that's because 1 squared equals 1. Centered at 0, 0 with a radius of 2. We'd have the equation x squared plus y squared equals 4. That's because our radius 2 squared equals 4. And then finally, the example we just saw, centered at 0, 0 with a radius of 3. X squared plus y squared equals 9. That's from 3 squared. All right, so looking at number 6, I can see that the center of the circle is 0, 0, centered at the origin. And the radius of the circle, if I go any direction, how about I just go straight to the right? I can see that the radius is 4. Okay, so the radius r equals 4. So if I want to write the equation of this circle, I know I'll have x squared plus y squared equals, and then on the right-hand side, I'm going to have r squared, which in this case is 4 squared, which gives me 16. So x squared plus y squared equals 16. All right, number 7, if the center of a circle is 0, 0 and the radius is a, if the radius is 5, what is the equation of the circle? That would be x squared plus y squared equals my radius squared, which is 5 squared, which would be 25. So x squared plus y squared equals 25. Now for b, if I have a radius of square root of 5, what is the equation of the circle? X squared plus y squared equals my r squared, which is square root of 5 squared. And the square root squared, those kind of undo each other, so I simply get 5. So this would be x squared plus y squared equals 5. So one common mistake I see here is people kind of go the wrong direction, especially if you have like a radius of 9, let's say, where it's a perfect square. So sometimes I see like x squared plus y squared equals 3, when it should really be x squared plus y squared equals 81. Just really pay attention to what your radius is and make sure that you're squaring the radius in the equation.